Okay, I'm going to do a short video here just to show how we can prove that two functional expressions are equal. Okay, so this is an example taken from class about 2 weeks ago, where we had a functional expression f is equal to a or d inverted ANDed with, we see what's inside the brackets here, and this is the full functional expression. And then what we did in class is we applied Boolean algebra techniques to reduce this down to its simplest form. And essentially what we're trying to say was that if we can reduce this expression down, well, we can actually make it for cheaper, right? So we applied various laws as we're going down, and what happened eventually is we ended up with the resultant expression being not A or B and with not C. So effectively what we need to be able to do is to take this resultant expression here and be able to say, well, that this expression, taking all of the inputs, is equal to this expression up here. So we have two different kind of components, one with fewer gates, and we use truth tables to be able to do this. So if I just jump into numbers here, so I have the original expression up here, and I have the reduced expression over on the right hand side here. So the first thing for me to be able to consider is, well, I have the letter A, B, C, and D. So I have 4 inputs. So 4 inputs should give me 16 rows. Okay, so what I'm going to write down first of all is, just put it on caps, is A, B, C, and D. And these are going to represent my initial inputs into this particular component. So if you watch the other videos on constructing the truth tables, what we say is we have 4 inputs here. So we have 2 to the power of 4 possibilities, which is 16 rows in our truth table. We take 16 divided by 2, we get 8 truths followed by 8 falses. And now I construct my table. So I simply say I'm going to have 8 truths in A followed by 8 falses. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. And 8 falses. Now when we look at B, well, B is going to be 4 truths. 1, 2, 3, 4, followed by 4 falses. 1, 2, 3, 4. Again, we repeat this pattern again. So we have 1, 2, 3, 4 truths, followed by 1, 2, 3, 4 falses. When I go to C, I have 2 truths, followed by 2 falses. And again, I go up to D and I say so now I have my initial construction of my table. Okay, and now let me just make those like that, and I'm gonna just center align these guys a little bit. Yeah, so these are just my initial, I guess, construction of the actual table itself. Yeah, okay, perfect. So the next thing for me to do is to actually look at this, and is to say, let me just clear that. Yeah, okay, so I have now my initial table inputs, and now what I need to be able to do is to look at the expression on the left hand side and build up the resultant functional expression. Okay, so how we do that is very simple. I'm going to take a look here, and I can see that I have not C and not A and a few other components. So what I'm going to start off initially with is looking at not A. We're going to use this symbol here for not and A. So the not symbol, as we've talked many times, simply if wherever you see a true, you then pass it through the inverter, which is the not, which then gives the opposite. So if it goes in as a true, well then after being inverted, it's a false. If it goes in as a false, after being inverted, it's going to be a true, right? So if I look at the pattern over here with A, I have 8 trues followed by 8 falses. So I'm simply going to have the reverse of that pattern. Oh. So then I have like this. So this is great. This helps me build up some of these components. I also have a need for having a not C. And if I look at the input for not C, well, it's going to be 2 trues followed by 2 falses. So I simply reverse that pattern. So I'm going to have 2 falses followed by 2 trues and repeat this pattern all the way down. So 1, 2. And all we're doing is constructing this table to help us actually build up some of these components. Okay, that's cool. So now I'm going to start building up, I suppose, these various things, right? So the first one is I'm going to have is A or D, yeah? Like this. Let me see. Just want to make those. Okay, so A or D. Now, the OR gate is simple. The OR gate simply says whenever we have a true, the resultant of that gate is going to be a true, right? So we're simply looking for a case where we have one true. So if we look at A, well, the first 8 answers for A are all true. So I know that A or D, well, it's definitely going to be true for the first 8 inputs coming from A. Now I also know that the second 8 in A is false. So this simply depends on what's going to happen with D. So if I have false or a value in D, well, the output is going to be true whenever D is true, or it's going to be false whenever D is false. So I can simply copy the last 8 elements from D. Okay, so now we have the startings of our actual expression. So now I'm going to have, let me just make this a little bit wider here. So, okay, now we have not. So I want to simply invert this, yeah? Okay, cool. So, and the inversion simply works the same, right? So I have the output of a particular gate, but I'm going to pass that into an inverter, and I'm going to get the opposite to what came in. So if I get the opposite to what comes in, so I'm looking at this column to the left, and I'm simply going to see wherever I have a true, it's going to become a false. Wherever I have a false, it's going to become a true. So I can see straight away that the first 8 of these are going to be falses. And now I just continue with the inversion. Remember, falses become trues, trues become falses, right way down to the end, right? So now we have the initial component, right? So, and this is the bit on the left-hand side, the A or D bar. The next is I'm going to have AB, right? So A ANDed with B. Now again, the AND gate is probably the easiest gate, right? Because what we can say with the AND gate is, well, wherever there's a false, it's going to be a false, okay? So if I look at the A input symbol here, well, the last 8 answers here, or the last 8 possibilities are all going to be false. So because I know that false AND with anything is going to be false, I can just simply look at the bottom of A and add it in. So I can now see here that I have true AND with something, right? So now this is going to be dependent on the term, right? So if A is always true for the first 8 inputs, well then if I have a true and a true, it becomes true. If I have a true and a false, it's going to become false. So what I can say here is that it's dependent on the value of B. And I can simply paste those answers in. Okay, so now we're starting to build up our thing a bit. Like, so now the next input we have is D and C. So again, if I look at C, well, I can see that the input is going to be true, true. So we have true and a true, and then we have a true and a false, yeah? So we consider this, so true and a true is going to be a true, true and a false is going to be a false, false and a true is going to be a false, false and a true, false and a false is going to be a false. Now all I'm doing is simply reading both of these columns here. Okay, so if we follow this down, false and false is false, true and true is going to be a true. Then we say true and false is going to be a false, false and true is going to be a false, false and false is going to be a false. And I can see the kind of pattern that I'm actually getting is true followed with 3 falses. And this gives us the pattern of those 2 input symbols being ANDed together. Okay, so now we have actually a great thing here, right? So what we need to have now is we have the full, I suppose, piece inside this particular brackets, right? So if I was to take this, and let me just highlight this a little bit. We'll highlight with yellow. So if I see I have the not A, I have, and then these 2 here as well, right? And what I want to be able to do here is to look at these, yeah, and then I want to construct a new table, or a new, I suppose, column. And it's going to be AB or DC or, and we say not A. Okay, now I'm going to extend this out a little bit, yeah. So we say AB or DC or not A. And all we're doing here is we're looking for whenever one of these is true, the output is going to be true, because that's how the gate OR gate works. So I can see with not A, well, the last 8 elements here are going to be true. So I simply go true, 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 and so on all the way down. And now I look and I know, because all of the first 8 inputs are going to be false, well, all I'm really looking at is these 2, right? And I say false or false, false or false, false or false is false, false or true is true, and then I have 4 trues. Okay, super, right? So now I have, this is what's inside the brackets, yeah? So let me just remove the highlights. Say no fill, and I'm going to go down here and it's going to take away the no fill, because what I want to be able to do is to just show what we're actually comparing now. Okay, so I can see now that I have to get A or D and then ANDed with whatever's inside the brackets, right? But we have the brackets here, that's cool. We have another symbol here which is B ANDed with not C. So I'm going to look at this first, yeah? So we say B ANDed with not C. Okay, very simply like that. Okay, so again, what we have to remember is that, well, once we see a false, well, it's going to definitely be a false, yeah? So if we look at B, B has 4 trues, right? And then it has 4 falses, right? So what we can do is we can go 1, 2, 3, 4, and then we have potentially, we have the 4 trues coming from B here. And now we have the last 4 will also be falses, okay? So wherever we have a false AND with anything is going to yield a false, so we simply can say that it's going to be false. Okay, so now we have, this is B AND with not C, and not C starts off here with a false, false, true, true, false, false, true, true. So we have a false AND with a true, so again, wherever we see a false, it's going to be a false, false, and then true and true. And we're going to rely on that pattern again. Okay, so now we have B AND with not C. Now, the last thing we have to do before we can look at the resultant expression here is very simple, right? So we have the A or D, right? So we're going to have, we need a bracket for this. So we're going to say not A or D, and then into AB or DC or not A. Okay, now this is going to be a big enough expression. Okay, and here we can see it here. So the nice thing about constructing truth tables is it's the same kind of thing, right? So let me see here. So we have, yeah, this should be A or D, yeah. So as we've said all along, right, so we're only dealing with 2 columns here, yeah. So we have this column here, which is the not A or D. So we fill this in yellow again, and then we can see that this is actually the inside. So this is what's outside the brackets being ANDed with what's inside the brackets. Okay, so when we look at this, wherever we see a false, the resultant is going to be a false. So this makes this task quite easy. As we can see here, if we look at the not A or D, well, I'm simply going to follow this down and we can see that we have a whole bunch of falses. Okay, now I have a true, so true and true is going to be a true, false is going to be false, true and true is true, false and true is false, true and true is true, false and true is false, and true is true. Okay, now I have this full expression from the A or D bar and with the AB or the DC or the inverted A. So what I'm going to do again is just get rid of this, right, because I don't want to cause any confusion. And now I'm going to have the full expression here. So we'll say F is over here. Okay. Now, if I look at F, so what am I going to have in F? Well, I need to have this term here, so which is the term we just calculated, right? And this is going to be passed into an OR gate with B ANDed with not C, which is B ANDed with not C here. Okay, and then here is also being ANDed with the not A. Okay, so now all we need to do here, so we have an OR gate with 3 inputs. When we look at the OR gate with 3 inputs, well, we simply need to see if anywhere we have a true is going to yield a true. Okay, so I can look at the not A, and I can see that the last 8 here are true straight away. So all I'm really looking at is the first 8 inputs. Okay, which will cause maybe a little bit of consideration. Okay, so now if I go back up here, I know that all of the not A's are falses, so here I have them here. I just need to compare these two, and wherever I have a true, which is simply false, false, this is going to be a false. False and false is false, false or false is false. True, true, false, 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 false. Okay, so now we have the resultant column for the full expression on the left hand side of the top here. Okay, so I'm just going to remove this, and what we'll do is we'll color this lad in here and we'll make him a light shade of green. So this is the full expression, right? And this is how the full expression yields the output. And what we're saying here is when we have those 4 inputs going into all of these various gates, well, the output is going to be what F has here. Okay, so now if we move on, right, and we say, okay, that's cool, right, but actually all this is B ANDed with not C or A, right, which is a bit obviously much smaller, right? So if I look here and I have all of these components already, so I can see that I have not A. This is going to be not A down here, right? And let's just highlight this. So we have not A or B ANDed with not C. So I have a B ANDed with a not C, which is here. Okay, and what we're saying is that if we have F2, which is the reduced expression, so this is F2, and F2 is actually just equal to not A or B ANDed with not C. Okay, so again, if I look at not A, well, I can say that I have 8 trues down here. So they're all going to be true straight away. Okay, and now actually all I need to do is copy in the top half of this, because it's going to be false or what's over here. Let me just highlight this in a slightly different color again. So we go here, and now what we need to be able to do is to actually look at all of these inputs. So we say, well, in the first input we have F is equal to F, F is equal to F, true, 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 false, 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 false. And we can see that for all of the inputs in our true table, we get out the same resultant expression in both of the full expression and the reduced expression. So effectively what we're saying is that we can build a component using all of these particular inputs, so having 4 inputs with all of these gates, or we can build the same component with only 3 inputs and much fewer gates, and they actually function the exact same. So we've just proven because these 2 resultant columns here in the truth table yield the exact same outputs when given the same inputs, we've proven that a reduced expression is the same or functions the same as the initial expression. Okay, thanks.